Did you know the sperm of a dying star impregnated the Earth? Stop talking dirty, please. Well, it's true. Let me first show you how stars are actually made, of spots called M, still heating us up with the speed of light. Here's a quick recap from the last episode. The start of our universe from a single spot that gets pressed into a magnetic field and then bounces off, setting everything around it into motion by exponentially repeating the same movement. This all happened at such tremendous speeds and heat that the magnoelectric spots, pressed together in a ball, exploded with a big bang. When cooled down, the strings of matter and energy form triangles that later on form negative and positive balls. So it's not turtles all the way down, but toroidal all the way up. We arrived at the first hydrogen, at the in-between level to our world and the one of perfect symmetry. Didn't go overnight, took a couple of 100 million years. That is because of the vast number of layers necessary to become a universe we can actually witness. Every level is a small upgrade to the previous, but similar universe. After about 250 million years, the universe is mostly made up of liquid or gassy hydrogen.
This is not an ocean of flowing water, but instead an ocean of hydrogen.
It's still vibrating because of the energy strings inside. And also important, the H atom doesn't like to be alone. It forms a bond with other H atoms by connecting the electrons in its outer layer, making it a bit more stable. Who said chemical elements couldn't be cute? And a welcome benefit, or maybe even a cause of why they bond, is the fact that the union causes some warmth. So for a long time, until the stars were formed, this H2 combination was the greatest of actual time. These balls of two hydrogen will grow to become gigantic balls on fire. Let the stars be born. Finally, here is bootylicious friction we can still witness today. The enormous clouds of hydrogen pairs condense under the force of gravity. Easier said, it is getting so crowded in this age of the universe that their cores are forced into each other. With heat and pressure rising up together, reaching a point of no return, two hydrogen 2 cores are squashed together and melted into one. This process will make up the core of stars, leaving one of the layers behind, which gives a little bit of energy, and so-called helium. Let's call her He. He looks like the bigger sister of H, but with a core of 2 protons and 2 electrons in the first shell.
When 2 helium-3 nuclei collide, they can form into even better combination, helium-4, and this releases tons of energy. Hydrogen is converted into helium in 3 steps. First, 2 protons are combined into deuterium through beta decay. Next, a proton is added to make helium-3. And finally, 2 helium-3 nuclei collide, creating helium-4 plus 2 leftover protons. To summarize, we present Children Explaining Nuclear Physics.
Hydrogen 1 atoms. The sun is made up mostly of these. Now, what if 2 of them collide? Then one of them will turn into a neutron and you get hydrogen 2. Next, it collides with another atom and becomes helium-3. And then it collides with another one and you get helium-4.
This, in a nutshell, is how gas clouds made of He turned themselves into giant flaming balls that heat up hydrogen around it in a different, cooler way. And when everything is in place, just the right amount of energy will give way to the perfect temperature that can start the life of planets around it. Well, I'm moving a bit too fast, because the first stars, called population-free stars, were unable to form a planet around them, since there wasn't any iron necessary for the core. Being more than 100 times bigger and brighter than our sun, the first stars just burned like crazy for a couple of 100 million years. But it also made them burn their hydrogen fuel at a much higher speed. This sounds awesome, and at the same time also quite boring without any Earth-like planets around. Back to the evolution of life. When a star runs out of hydrogen to fuse its core, it begins to contract and heat up because of the constant pressure inside. When the core temperature rises to 100 million degrees Celsius, 6 times hotter than our sun's core, helium-4 particles fuse fast enough to produce significant amounts of stable carbon-12, an even heavier metal. Carbon will later on be used in plants and all kinds of things. We even have an environmental problem because of it right now. When carbon fuses with helium again, this process makes oxygen, which will be the fuel strong enough to make all water on Earth. This goes on and on for quite some time, where new metals form after the old ones combine with helium or with themselves. Stars around 10 times the size of the Sun will have a crazy hot core of iron, the densest element forged in stars. I almost forgot about nickel there, with 28 atoms in the center and 28 in all of the outer shells. The big difference in all of them is just that the core of heavier elements has more protons and neutrons and thus a harder shell of more electrons, like 26 within iron. This is what makes it tougher, more balls closer together. When there's nothing left to burn, a gigantic iron ball remains, which, if it doesn't explode under its own gravitational force, we humans will later call a black hole. But there is no hole, only a gigantic amount of dead star at a dark matter state, desperate for all energy. At every galaxy of stars lies a black hole at its center that keeps its magnoelectric galaxies of stars and planets orbiting around it. In our Milky Way galaxy, the remains of such a star, a quasar, is called the Sagittarius A-hole. But most of the first stars didn't turn into a black hole, but exploded in a similar way as the Big Bang. When graviton overdoses it again, overpressing the hot core, these dying stars explode brighter than 100 galaxies, ejaculating the metals inside at the speed of light into the surrounding universe. This is the beginning of the life of magnoelectric planets, because they can now form a core from the molten iron made in dead stars. Around its magnetic core we find magma that will form the crust on the outside, you know, the one we walk on and call Earth. It's still made from star semen like oxygen, silicon and aluminium, iron and magnesium. All created as one family of metallic cousins and nieces, brothers and sisters of the hydrogen pressed together in the heart of a star. They will all help create life as we know it, even before the first one-celled water creatures moved here on Earth. Cause yes, it would be overly arrogant to claim our planet as the first to have life. Let's not make that mistake again. It is unsure when life first appears, especially since we haven't decided on a definition for what life is. Do we mean chemical life or biological life? All biological life has chemical life in it, and even smaller, magnoelectric balls forming the chemicals in every biological body. But at some point we decide it's more than just chemical life. This complex life comes from either the combination of elements on planets like we all are, or from the combination of stars and galaxies in the universe. The second god in our story arises from the latter, the combination of stars and galaxies in the universe, while there may just be, although we don't see, a greater overlord deity that makes use of the enormous amount of energy. Does the bigger universe think? Use its stars and planets and nebula as a gigantic brain, where a web of some sort creates consciousness ungrabbable for little water creatures like ourselves? It's got a computer. Dat is een lastige vraag. En zoals het in de filosofie zo vaak is, op echt lastige vragen heb je nooit één antwoord. Het is altijd ja en nee tegelijkertijd en iets ertussenin. Hetzelfde geldt voor, ben ik een aap? Ja, en ook nee, want ja, het is... Ja, oké. Meer daarover volgende keer en je kan zelf ook al wat antwoorden bedenken. Dus laten we kijken of God een computer is als we nee zeggen. Op welke manier niet? Ik heb hier een computer en daar is Mario aan het tennissen. En hij denkt dat hij een prachtige wereld aan het bewonen is, die heel erg echt is. En misschien geldt dat voor ons ook wel. Maar deze computer heeft een maker, Nintendo in Japan. En Mario die bestaat niet op dezelfde manier. Het is een laag in een laag die onze realiteit is. En onze realiteit lijkt misschien wel op die van een computer, maar uiteindelijk is het dat niet. Dus nee, God is geen computer zoals wij hem ervaren. En zelfs als we straks een quantumcomputer bouwen die werkt met de meer nulletjes en eentjes in twee posities, zoals de kleinste deeltjes in de natuur ook zouden werken, dan nog is dat niet vergelijkbaar met het universum waar wij deze bewegende karakters zijn. Het grote verschil zit hem erin dat, ondanks dat je mij ook nu digitaal ziet en alleen de voorkant en de 3D-stukje gewoon in je hoofd doet, ben ik wel meer 3D dan ik nu op je scherm ben. Ik ben van vlees en bloed, wat natuurlijk kleine deeltjes zijn die ook gewoon in de sterren afkomstig zijn. Maar uiteindelijk is het wel meer inhoud dan dat digitale poppetje wat daar aan het tennissen is. En een ander heel groot verschil is dat als zijn we op een computer, dan zijn we wel op een geniale quantumcomputer die met veel kleinere deeltjes nog werkt dan de pixeltjes op je eigen scherm nu. Met een universum gemaakt van spots kun je deze wereld alleen creëren die zo stabiel is omdat alles op precies de juiste temperatuur trilt. Maar goed, even ter geruststelling. Stel we zitten wel op een computer, net als Freeman als non-playable character er uiteindelijk achter komt en bewust wordt van zijn omgeving. Zo zijn wij wellicht ook uit onze geprogrammeerde omgeving ontsnapt en hebben we bewustzijn gekregen om mee te denken en te praten. Stel dat het allemaal waar is, het zou gelukkig helemaal niks afdoen aan hoe mooi de wereld is. Er verandert eigenlijk helemaal niets. Er zijn ook heel veel mensen bang met die balletjestheorie die ik nu heb en de spottheorie, dat het allemaal de wereld heel erg chemisch en koud maakt en kil. Maar dat is helemaal niet zo. Het zijn nog steeds dezelfde mechanismen in ons die ons empathie en emotie en uiteindelijk ook een geest kunnen geven. Dat de geest uiteindelijk een materiële bron heeft is voor sommigen heel moeilijk te behappen, omdat het iets anders belangrijks weghaalt, namelijk de mogelijkheid van een ziel na het leven. Maar wat ze vergeten is dat we via onze genen mogelijk een hernieuwd leven hierin kunnen hebben. Als we dat maar doorgeven en blijven bestaan, is er vast wel weer ruimte om nog een keertje een leven te mogen leiden. En ik vind dat gewoon fucking tof. So, in conclusion, our hydrogen friend is never far away. To keep us, water creatures, hydrated, fueled up for adventures. But it all started out simple, when hydrogen combined with oxygen formed within stars made water balls that filled up the oceans. With ice below zero, gas above 100 degrees and liquid in between, water has all the common states of matter right here in our hands. And in them, the other star metals like carbon form the outer layers of plants. And that is one step away from a basic one-cellular water creatures, who is able to grow, move, and have boring sex in the form of basic cells that need to have genetic sperm inserted to reproduce. Next episode, I'll tell you what this means for sex evolution. I know you already know you have to use protection for, something out of nothing happening in someone's belly. But did you know the sperm of a dying star impregnated the Earth? Okay, yeah, you do now. We went from nothing to everything in a split second. Real life filled with electromagnetic animals wandering around, asking themselves what to eat next or whether God exists or not. The one all other simulations, like this one you are seeing now, are built upon, with all of its beauty and ugliness and with everything in between. Still humble but with a bit of pride, realizing we are the universe that became conscious in this basic version of nature. Hoi? Ja? Oh, je handschoenen, hè? Ja, je handschoenen zijn nog hier inderdaad. Oké, moet ik ze langs brengen of kom maar me langs rijden? Oké, ja, is goed. Dan ik kom ze wel even brengen, ja? Of heb je... Oké, is goed. Doei.